Hello everyone and welcome back to my channel. In this video, I will discuss to you about the meiosis. Meiosis employs many of the same mechanisms as mitosis. However, the starting nucleus is always diploid, and the nuclei that result at the end of a meiotic cell division are haploid. To achieve this reduction in chromosome number, meiosis consists of one round of chromosome duplication and two rounds of nuclear division. Because the events that occur during each of the division stages are analogous to the events of mitosis, the same stage names are assigned. However, because there are two rounds of division, the major process and the stages are designed with a 1 or a 2. Meiosis 1. Meiosis is preceded by an interphase consisting of the G1, S, and G2 phases, which are nearly identical to the phases preceding mitosis. The first phase of meiosis 1 is prophase 1. During prophase 1, chromosomes condense at the nuclear envelope fragments. Homologous chromosomes bind firmly together along their length, forming tetrad. Chiasmata form between non-sister chromatids. Crossing over at the chiasmata, spindle fibers emerge from the centrosomes. Prometaphase 1. During prometaphase 1, homologous chromosomes are attached to spindle microtubules at the fused kinetochore, shared by their sister chromatids. Chromosomes continue to condense and the nuclear envelope completely disappears. Metaphase 1. Metaphase 1 is the third phase of meiosis 1. During metaphase 1, homologous chromosomes randomly assemble at the metaphase plate, where they have been maneuvered into place by the microtubules. Anaphase 1. During anaphase 1, spindle microtubules pull the homologous chromosomes apart. The sister chromatids are still attached at the centromere. Telophase 1 and cytokinesis. During telophase 1 and cytokinesis, sister chromatids arrive at the pools of the cell and begin to decondense. A nuclear envelope forms around each nucleus, and the cytoplasm is divided by a cleavage furrow. The result is two haploid cells. Each cell contains one duplicated copy of each homologous chromosome pair. Meiosis 2. During meiosis 2, the sister chromatids within the two daughter cells separate, forming four new haploid gametes. The mechanics of meiosis 2 is similar to mitosis, except that each dividing cell has only one set of homologous chromosomes. Therefore, each cell has half the number of sister chromatids to separate out as diploid cell undergoing mitosis. The first phase of meiosis 2 is prophase 2. During prophase 2, sister chromatids condense and a new spindle begins to form. Then the nuclear envelope starts to fragment. Prometaphase 2. During prometaphase 2, the nuclear envelope disappears and the spindle fibers engage the individual kinetochores on the sister chromatids. Metaphase 2. During metaphase 2, the sister chromatids are maximally condensed and aligned at the equator of the cell. Anaphase 2. During anaphase 2, sister chromatids are pulled apart by the shortening of the kinetochore microtubules. Non-kinetochore microtubules lengthen the cell. Telophase 2 and cytokinesis. During telophase 2 and cytokinesis, chromosomes arrive at the pools of the cell and decondense. Then nuclear envelopes surround the four nuclei. Cleavage furrows divide the two cells into four haploid cells. Meiosis. Meiosis is a series of events that arrange and separate chromosomes and chromatids into daughter cells.